and welcome back to another Generative Components tutorial. Today, we're going to use some recursive power. I think scripts like this are such a powerful tool in generative design and automation. Setting up a system where it can make a decision and act on those is taking things to the next level. For this example, we'll take a simple grid of polygons and generate a paving pattern along a B-spline curve. So let's get started. Here we are in a fresh file called Recursive Path. I like to work in wireframe view, and for this exercise, I'll start in a top view. Let's click on the point tool to set up a quick base yes by clicking on yes and OK. But for this, I'm going to drag in a point node, as I'd like this to be a point grid, and we can do that from a single node. So we drag in a point node, and let's change its X translation to series, open brackets, 0, 10,000, 1,000, and close brackets. So this is basically a series from 0 to 10,000 in steps of 1,000. And now you can see we have a series of points generated in the X direction. So let's change the Y translation to a series, open brackets, 0, 6,000, 1,000 in close brackets. And now you can see those points are moving in a diagonal direction based on the X and Y inputs. For the Z translation, I'm just going to set that to 0. Now to get a grid of points, it's just a matter of right-clicking on the node and then clicking on Switch Replication Style. This will change it to all combinations of X, Y, and Z. With the point grid set up, let's drag in a Polygon node and change its method to by point grid and just link that up to point 1 node. And now we have a simple grid of polygons. Now for the path, we're going to be using a B-spline, and we could just draw that by selecting the B-spline tool, but I wanted to drop down some points first and show you how to link those up. So I just dropped down 5 points and then dragged in a B-spline curve node. So the curve passes through those points, I'm going to change the method to by points. And then I can zoom out a bit, and then by clicking in the input box of the B-spline curve, I can then drag a selection over the points I need, and the input field is automatically populated. So now we have the basis for our paving pattern, let's start creating a new function that will do all the work for us. Before we start this, let's take a look at a simple breakdown of what a recursive function will do, and in my simple terms, how I would describe what it's actually doing. If we start with a rectangle, and say ask a question, say how big is it? If it's larger than a certain size, let's divide it up into 2 pieces. Now let's ask the same question of the 2 new rectangles. If they are larger than the size we decided, let's divide those as well. And this will continue until that question returns an answer of no, or in our case, false. As you can see, it starts to look like a tree, and each of its branches takes its own path. Now each branch doesn't need to be the same length, they can be different. It's all defined by the question you ask and the results that's returned. And this could be a number of questions. Is it larger than a certain area? Or are the lengths of its sides, are they longer than a set length? It could be anything, but it needs to return a true or false answer for each question. So how do we do this in a function? Well, let's click on the Model tab and click on the Functions icon to open up the Functions dialog. On the top left, there's a small icon of an F, and this will create a new blank function for us. So looking at the default, it starts with the word void followed by function. So let's change the void to polygon, as this function will return polygons for us. And we can change the word function to give the function a name we can call on later. Now I'm going to call this Subdivide Polygon. As with all functions, we can put our inputs into the close brackets section after the function name. For this function, let's set up a polygon and let's call it polygon2subdivide. This will be the polygon we'll be looking at to divide up. A double, and let's call that minimum size or min size. This will be a minimum edge length for the sides of the polygons we're looking at. And then let's set up a B-spline curve and call that path curve, which will be our input curve that we would like to use for our pattern. Clicking apply on the dialog, we can now see that a new function has appeared in the list, and it's called Subdivide Poly. Now we just need to add some content into the function. As I like to do for each function, the first line is the final output I'd like from the function. In this case, polygon, and I will call that myPoly and equal that to open and close curly brackets or an empty container. The next line we'll set up is an answer variable, starting with the word bool, and then we'll call it poly need subdivision. And we can start with the answer equals false. And we're going to use this answer later on. The main question I'd like to ask in this function is, does the B-spline curve cross over the polygon we're looking at? So to get an answer for that question, I thought the best approach would be to temporarily create some lines from the vertices, and then generate a point at the intersection between the lines and a B-spline curve. So let's set up some lines to start with. So we'll start with line, and I'll call this edge lines, equals new line, open and close brackets, dot by chaining, open brackets, poly to subdivide, dot vertices, and then comma, true to close the line back to the start, and then close brackets, and then a semicolon. Now you may ask, why not just use the polygon segments that we already have? And I think it's a bit harder to determine where you are in a tree in order to find the intersections along those polygon segments. And the added time here in creating some temporary lines is not that much of an impact on the performance versus the complexity of trying to find the depth you might be for the relevant polygon we're looking at. So moving on, let's look at how to capture a point between these. To capture if the point is generated between the edge lines and the B-spline curve, I'm going to set up a small little counter. And it's going to be an integer, so int myCount equals 0. I'll show you how this is used shortly. Now let's set up a loop to look at each of the edge lines. So let's type 4 and then tap tab a couple of times and it'll auto-generate the text string for a loop. And we can copy edge lines text and paste it into the loop just before the count and put .count with a capital C. I'll indent this part so it's a bit easier to read. To check for the intersections, I'll use a simple point. So let's set up a point and I'll call it int point equals new point, open and close brackets, at curve intersections. Now we need to work out what intersections we're going to use. So let's go open brackets and say edge lines in square bracket I, so the line we're currently looking at, or the segment we're currently looking at, comma path curve, so the curve we're going to intersect with, comma null for the I direction, and another comma, then null for the I point, and then a comma, but the last variable needs to be false, as we don't want to treat these lines as infinite. Then we can close the brackets and add a semicolon. Now we can ask our first questions, starting with the word if and our open brackets. And this is where we ask the question, int point.success. So was the point successfully created? And then we can close the brackets. This doesn't need any other text like equals equals true, as the if statement is a bool, it's expecting either a true or false answer. So the one thing you need to make sure is that the question you ask in the brackets can be either answered with a true or a false. If true, it'll proceed with the next part of the if statement. In our case, the next part of this if statement will be myCount equals myCount plus 1. So we're going to increment the counter by 1. And I forgot to place the curly brackets, so let's place some curly brackets at the start and end of this line, as this is part of an if statement. Curly brackets don't need to be on a separate line. It just makes it a bit easier to read, I think, if you put the curly brackets above and below the line of the function. But if you want to, you can compress this into a single line. Now we have a count of the number of successful points of intersections between the path curve and the polygon. So next, I'd like to ask some additional questions before we decide to answer that main question, does the polygon need to be subdivided? Starting again with if and open brackets. Again, now I can ask if my count is greater than 0. So if there are any successful points, well, let's have a look at that. And then we're going to do and, which just means and another question. And the other question might be edge lines, bracket 0, bracket, dot length is greater than the minimum size, the min size. This will ask if the first segment of the edge lines is longer than our minimum size that we set. So let's do and again and add another question. So edge lines, brackets 1 dot length is greater than min size. And then this just checks the next segment in the edge lines. For this example, I know that by checking, say, segment 0 and segment 1, I've checked both the length and the width of my polygon, so there's no need to go on and check the other segments, but you could easily do that as well. Now you can close the brackets, and now let's place some curly brackets for the if statement. And inside these, if all of the above is true, we want to set poly need subdivision equal to true. And now we can get to the main part of the function. If the polygon needs to be subdivided, we should go and start to do that. So let's start with an if statement again. So if, open brackets, poly need subdivision, close brackets. Now we can open and close curly brackets for this if statement. Now I would like to divide the polygon up into 4 new polygons. So to do that, I'm going to place a point at the center of the polygon and then a point at the midpoint of each of the sides. So let's start with the word point and call that centroid, and equals new point, open and close brackets, dot centroid of set, open brackets, poly to subdivide dot vertices, and then close brackets and semicolon. This will generate a point at the centroid of our set. Next, let's set up another point. So type point, and we'll call this bot mid. So bot mid for the bottom midpoint equals new point, open and close brackets, dot by parameter along curve, open brackets, and we can use edge lines, open and close square brackets with a 0 for the first segment of our polygon. And for the parameter, it can be 0.5 for the midpoint. And we can close brackets and then put a semicolon. Now we can do the same thing for right mid, top mid, and left mid, each by changing the edge line segment to the next segment number. I will leave myself some notes here for the future so I can remember what I'm doing. And you can just start those comments with the double forward slashes. With all the points created, all we need to do now is create each polygon. Now this is where all the magic happens. What we need to do is create new polygons inside a line that is adding polygons to our my poly container. This is probably the most confusing part of the function. So let's complete the line and I'll break it down a bit. So myPoly.add. So the first part is just saying we'd like to add something to the myPoly container, and then we open the bracket. Then we do something a little bit strange. We call Subdivide Poly function, or we call the same function that we're actually writing now. We do this because the item we want to keep checking is the polygon we're about to create. And we want to check whether it needs to be subdivided as well. So we pass it back into this function again, and it starts the branch of our tree structure. And that is the key of recursion, calling the same function within that function. So now we do that call with Subdivide Poly, and as we know, it requires 3 inputs: a polygon, a double, and a B-spline curve. So inside some brackets, we can now create the first of our subdivided polygons. So we type in new polygon, open and close brackets, dot by vertices, and then open brackets. Now for the vertices, if we think about a polygon and the points that we just created before, we want to start at the bottom left and then rotate anti-clockwise. So we can start with poly to subdivide dot vertices, square brackets 0, so the 0 point of our original polygon we want to subdivide. Then the second point is going to be comma bot mid, so the bottom middle point, comma centroid, comma left mid, and then we close the brackets. So this creates the polygon that we needed, and now we can place a comma, and then we can pass in min size, and then another comma, and then pass in path curve, as these are the other constants we want across all the subdivisions. Then we need to close brackets twice and put a semicolon. So we can just copy this line and paste it 3 times, and changing the vertices to create the new polygons. So for the first one, it'll be bot mid, comma poly to subdivide dot vertices in square brackets 1, comma right mid, and comma centroid. Then the next one will be centroid, comma right mid, comma poly to subdivide dot vertices in brackets 2, comma top mid, and finally the last one is left mid, comma centroid, comma top mid, comma poly to subdivide dot vertices in brackets 3. So now we have set in motion the recursion. What happens if the polygon doesn't need to be subdivided? This can be handled with the else statement. So let's type the word else and then put in some curly brackets. And then inside these, we can set myPoly equals new polygon, open and close brackets, dot by vertices, open brackets, poly to subdivide dot vertices, and close brackets, and then a semicolon. And this will create a single polygon, which is the result of the limit of that branch, if that makes sense. So if you think about it, this is the end of the branch and it only has one result, and this is it. And then finally, we can type in return and then myPoly, and then we click apply. And I have an error. Oh, I forgot to place a semicolon at the end of myPoly and the return. So doing that, I can click apply again and it's all happy. So now we have a new function, but how do we use it? It'll be a polygon, so let's drag in a new polygon node and change its method to by function, and then open up the editor by clicking on the square. We start with the word function, and then we open brackets for our inputs. So let's set up 3 inputs. One being our polygon, and let's call that input poly. The next will be a double, and let's call that min edge length, and then comma. And finally, let's type in B-spline curve, and we'll call that input curve, and we'll close brackets. And then we set up some curly brackets for our function. Inside those, let's first of all set up a container for our output. So polygon myPolyArray equals open and close curly brackets, and then semicolon. As I'm going to use my polygons we created from a point grid, and that's already an array. So we're going to loop through the array to create our new polygons. So then we start our first loop. So we type in for, and we tap tab a couple of times to generate that line. And then we copy input poly, and we paste that in before the count and put in a dot. Now inside this loop, we want to set up a list. So polygon myPolyList equals open and close curly brackets with a semicolon. And now we can start our second loop. So we type in for, and we tap tab a couple of times again. And now if we change the first I to J and press tab, it'll auto change the other I's over to J for us automatically. Now we can just copy in input poly and paste it in before the count. And now we're going to include in square brackets I and then dot before the count. Now we're just looping through that row in the array. Now inside this loop, we're dealing with individual polygons. So this is where we'd like to use our subdivide poly function. But what we want to do is add the results of this to our poly list. So let's start with that. So myPolyList.add and then open brackets. So now we can call the function. So let's call subdivide poly and open brackets. And as we know, this requires 3 inputs. So we can pass in the polygon we're looking at. So in this case, it's input poly square brackets I square brackets J, comma. For the length input, we can use the min edge length that we'd set up as an input. And for the B-spline curve, we can use the input of input curve. Then we can close brackets and close brackets again and a semicolon. So then in the next section, we have to add this list to our poly array. And I can do that with myPolyArray.add, open brackets, myPolyList, close brackets and a semicolon. And finally, at the end, we need to put in return and then myPolyArray and semicolon. Clicking apply and then close this window. Now we can see the inputs on our node. So for the minimum edge length, let's put in 500. For the input curve, let's link that up to the B-spline curve 1. And for the input poly, we can link that up to polygon 1 node. And like magic, we get some subdivided polygons along the B-spline curve. We can test the script by changing the min edge length to say 200, and now we have even more subdivisions. One important item to mention is the polygons that are returned are at different depths. For example, this polygon is polygon 2, square brackets 6, square brackets 1, square bracket 0, square bracket 0, square bracket 3. And each polygon could be a different depth based on how far down that branch it went before finding a polygon that met our requirements. So take this into consideration if you're using this in a subsequent step. You might need to flatten this list to make it more usable. If we change the minimum edge length back to say 800, we can now drag around the points and the B-spline updates, and now you can see the polygons update as well. So changing the edge length to 50, we now get an even finer result. Now this does slow things down a little bit, so there might be some areas we can refine. So let's go to the Model tab and open up the Functions dialog and click on Subdivide Poly and click on the Edit icon to access the editor again. One area to improve efficiency maybe is not to look for intersections before we check that the edge length's over our minimum length. This would save a round of computations that may be not needed. Let's copy the bottom if statement and paste it above where the point is created. We can delete my count check and just ask the questions about the edge lengths. So we need to make sure we place some curly brackets that contain the creation of the points. And now we can adjust this second if statement to remove the edge lengths check, as we've already just moved that above. That should provide some benefit. Another area I found that has caused me some issues in the past is if I don't have a safeguard against my own errors. So if we do something that never gets to a conclusion, the script will run forever. And trust me, this is very easy to do. So let's put some more variables in the inputs at the top. Let's put in an int and call it depth, and put in another int and call it end depth. I'm going to use these as a method of limiting how many times the recursive function runs, no matter what the other variables are set at. So let's add into the second if statement, and depth is less than end depth. Now we just need a way to increment the depth each time the script runs. And this can be done down in the recursive section. And this is quite easy. As we've added 2 inputs to the top of the function, we actually need to add those 2 inputs now down into the recursive section as well. And as we pass them in, we could increment the depth by 1 each time it passes through this part. So let's add a comma and then add depth plus 1, and then another comma, and then just put in end depth. And we can add that to the end of each of the lines in this section. We can now press apply and return to our graph window, and the polygon 2 now has an error as we've just changed the number of inputs required by the Subdivide Poly function. So opening up the polygon 2 function, going down to the inputs for the Subdivide Poly, for the first of these we can place a 0 because we want to start the depth at 0, and let's create an input for end depth. I'm going to type in up the top an int, and let's call this iterations. So we copy iterations and let's paste that down into the Subdivide Poly line, finish off the required inputs. We can click apply and the new inputs have been added to our node. So let's type in 1 into this input and we can see the polygons have been divided just once, even though our minimum size is set to 50. And we can change this to 2 and they subdivide a second time, and we can change it to 3 and they subdivide again, etc. This will continue until one of the other limits has been reached. And this is a great way to test out your recursive scripts with a bit of a safety net in place, so you don't lock up your computer with an endless running recursive script. Hopefully you'll find a way to incorporate this into your next project. Until next time, thanks for watching.